So in a previous lesson, we looked at some reaction energy diagrams, those for exothermic reactions and those for endothermic reactions. We then introduced a catalyst to those reaction energy diagrams and showed the example of what happens for an exothermic reaction. I assigned as a homework problem to write a reaction energy diagram for an endothermic reaction with the addition of a catalyst. So the homework problem was just to do the reaction energy diagram for an endothermic reaction. We call this a reaction energy diagram, but if we're describing this or writing a title for this the way that we do for a lab or homework or something, we'd say how the progress of a reaction or an endothermic reaction affects the enthalpy of the reaction, that is the enthalpy in the system here. In this case, for high school at least, we're pretty much talking about the energy stored in the system. So this is our reaction progress down here. Okay, you could label this as reactants and products. Okay, that's fine too. Either one or both or either one is probably fine. These are reactants going to products. So either label on the x-axis is acceptable. And so when you have let's see, for an endothermic reaction, with a catalyst. Okay? And so for an endothermic reaction, we're always going to start low and end high because we're adding energy to the system. So at the end, you need to have more energy than you had at the beginning. Okay? So we're going to have more energy at the end than we had at the beginning. Okay? And you always have to have the activation energy. And the activation energy has to be higher than anything else. But these are for simple reactions. Very often in reactions we actually have multiple activation energy hills. But for us, we're just going to treat it as if it's one for right now. Okay? The difference between the starting amount of stored energy, remember we're talking about it being, delta H as being stored energy, but in fact, it's more than that. We're going to, we're just kind of simplifying it for high school chemistry. So delta H is what this is. You might also call it the change in stored energy, but you need to label it in somehow. You might also label it as enthalpy in the system or something. Okay? No, this is we're checking your homework right now. No, we're going to get to something else to use that for. Okay? All right. And so the activation energy always goes from whatever the beginning energy is to the top of that energy hill. Oh, try to spell here. And activation energy, you don't have to have this for this graph. Just to define it for you and be clear. Activation energy is the energy added to the system to initiate or start the reaction moving forward. Okay? And then when you add a catalyst to the system, okay, a catalyst reduces the amount of needed activation energy. Okay, so this is the effect of a catalyst. Okay? And so that's when I ask you to draw a graph that shows the effect of a catalyst on an endothermic reaction using a reaction energy diagram. And that was the homework assignment. This is what I'm expecting. I want you to label everything so I know, you know what everything means. Okay? So let's talk about how to grade this then. All right? You have to have your axes labeled properly. Okay? So you have to have enthalpy or delta H over here. One or the other is fine. Okay? But you have to label the axis. It has to be labeled properly. You have to label this axis. And I said a moment ago that reactants going to products is acceptable. I would accept also reaction progress. Either one or both is fine for a point for labeling the axis. Okay? All right. You've got to have the reaction energy hill working like this, where you start low and end high with an activation energy. So we're going to give 1 point for starting low, 1 point for ending high, 1 point for the activation energy hill being up here. Okay? You're going to have a point for labeling this as activation energy. Now, how you do that is kind of up to you. If you drew an arrow here and then label it activation energy, or just wrote activation energy here, that's okay. If you wrote the word activation energy, just pointed the top of the hill, I would accept that. Okay, but you have to properly label what the activation energy is. That's a point. Okay, you have to label what the change in enthalpy is. Okay, in the system. All right, you can call it delta H. You can call it change energy stored in the system, change in energy stored in the system, enthalpy in the system. Any of those things is acceptable. Okay, but you have to label properly this change in energy from beginning to end. Okay, and then you have to have this line or curve rather here that shows what's happening with the catalyst. The catalyst shaves off or cuts down the height of the activation energy needed to move the reaction forward. That's required, and you have to label it. Okay? You can call it just catalyst is fine, but the effect of the catalyst is probably better. Everybody understand what we're doing? So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Okay, now that's what we've got so far. Every graph has to have a title. You have to label it as a reaction energy diagram. You should label it for an endothermic reaction with a catalyst, but at least you've got to have a title up there. Okay, so that's your 10th point right there. All right, now in the future, when I ask you to do homework, we have a graph. Give me a complete title. Okay, don't save on the pencil graphite. Okay, thinking I don't have to do that. Yeah, you do. Better to have too much than not enough. Yes. Now there's a little bit of a balance there. I mean, I don't want you to write a whole paragraph for a title, but be complete about your titles. Okay? I'm not expecting you to write a figure label this time. For a formal graph, you would, but for this graph, where you're just describing what's happening as your reaction progresses to the energy inside the system, just the reaction energy diagram is probably sufficient. It wouldn't be complete really without saying an endothermic reaction with a catalyst. But for right now, here near the beginning of the semester, not right at the beginning of the semester, but about 3 weeks in, I'm being a little bit lenient about what I'm expecting. I'm expecting you guys to kind of pick it up as we go along. Everybody understand? So the whole thing is worth a total of 10 points. All right. If you do your homework on time and you blow it, so you do poorly, you can do a makeup and get all the points back. If you don't do your homework on time, then whatever makeup you give me, if you turn it in the next day, you lose 10 points or 10%. Turn it in the day after, 20%. Okay? So do your homework on time, even if you mess it up, because you can do the makeup and get all the points back. You got that? All right.